Two fair dice, one red, one blue, are rolled. Let A be the event that the number rolled on the red die is odd. B be the event that the number rolled on the blue die is odd. Let C be the event that the sum of the two numbers rolled is odd. Which of the following is true? Okay, we're talking about independence. Now, it's clear that each die and the sum is equally likely to be odd or even. So each die is 1 through 6, so it's equally likely to be odd or even. And the sum, you know, by symmetry, if you look at the 6 by 6 array, when two die are rolled, you see the sums alternate in these 36 points. The sums alternate being odd and even. So like 1 1 is even, 1 2 is odd, 1 3 is even, and so on. So the sum is the C event, and so it's the C event. C event is the sum being odd. So probability of C is 1/2 as well. Okay, now we know that two events are independent. So now it's very clear that A and B are independent because A is first die being odd and B is second die being odd. And whatever one die shows has nothing to do with the other one. So A and B are obviously independent. Now to see whether A and C are independent, for example, we use our basic mathematical result that two events X and Y are independent if P of XY equals P X P Y. Now from the picture, we can see that, okay, so let's see what's P of AC. P of AC means that A and C, so remember AC was our shorthand notation for A and C. So A means that the first die is odd and C means that the sum is odd. So first die odd and sum odd, there are 9 points which do that. So for example, you know that out of these 36 points, there are 18 points where the sum is odd. So like 1, 2, 1, 4, 1, 6. So like 2, 1, 2, 3, 2, 5, and so on. And you'll find 18 points where the sum is odd. And out of these 18 points, half of them have the first component odd. So first component odd is the event A. So like these three, the 1, 2, 1, 4, and 1, 6, they are the ones where the sum is odd and the first component is odd, which means the first die is odd. But in the 2, 1, 2, 3, 2, 5, the sum is odd, but now the first one is even. So also by symmetry, you can count that there will be 9 points where you'll have the sum odd and the first component odd. But it's also obvious from symmetry. So it's 9 out of the 36 points. So the probability of AC is 0.25. Now probability A, probability C is 0.5 times 0.5. Remember we already stated that A and C, A, B, C all have probability 0.5. So that's 0.25. And so from 1 and 2, we see that probability AC equals probability A, probability C. Therefore, A and C are independent. Similarly, B and C are independent because A was the first roll, B was the second roll, and C was the sum. So we've shown that each pair is independent. Remember, A and B were already independent. Since what you get on one die has nothing to do with what you get on the other. And now we have also shown that A and C and B and C are independent. All the three pairs are independent. However, that doesn't mean that all the three events together are independent. For that, we must have P of ABC equals PABBBC. Now, PABC is 0 because the three events cannot occur at the same time, because if first and second occur, then it means both the die are odd and therefore the sum is even. Therefore, C cannot occur if both A and B occur. Remember, C is the event that the sum has to be odd. So probability of A and B and C is 0, but PA, PB, PC is 0.5, 0.5, 0.5, and so PA, BC is not equal to PA, PB, PC. And therefore, the three events together are not mutually independent. And now choice A says exactly that. If you go up, choice A says that three are not mutually independent, but each pair is, and that's what we've just established.